If you look up at the sky on a clear night from the northern hemisphere, you may see the constellation Cassiopeia. You may already know how to spot its familiar pattern of bright stars. What you may not know is that when we look in this direction, we can find many sites of new stars forming in our own galaxy. One of these, more than 6,000 light-years from Earth, is called W5. Here it is in optical light, which is the type of light visible to human eyes. Although it's too small and faint to spot with the naked eye, with a powerful backyard telescope you could see an image like this one. This region spans about 300 light-years across. Keep in mind the distance from the solar system to the nearest neighbouring star is only about 4 light-years. In the middle of W5 are several massive, hot blue stars that are about 30 times the mass of our Sun. These big stars, which astronomers call O stars, heat up and excite the surrounding gas and dust. The faint diffuse glow you can see in this optical image is emitted by hot gas. This next image shows W5 in infrared light. Because our eyes can't see at these wavelengths, a computer has added false colour. The red glow is showing the emission from warm dust. This is not like the dust in your home though, it's actually microscopic bits of carbon and silicon. Astronomers look at places like W5 to study how stars form and how one burst of star formation can cause another to start nearby. In W5, we think there may have been 3 successive generations of star formation. One member of this first generation is this star, right in the middle. It is actually very massive, and stars this large usually form in groups. You may notice, however, that it's not in a particularly crowded environment. We think this is a clue to its life history. It probably formed here, and the stars that used to surround it have dispersed over time. The next episode of star formation may have been triggered by these first stars. As their huge energy output and stellar winds blew material away, gas and dust clumped together and collapsed to form the second generation of stars. Here they are in these large clusters. Right in the middle of this group are 4 more massive blue stars. W5 is so far away that they appear to be a single dot of light, even when we look at them with the biggest telescopes. However, astronomers have studied the changing light they emit to infer the presence of multiple objects in this bright point here. Clustered around these massive stars, many other smaller stars have formed, most of them still surrounded by a disk of leftover material that could maybe form planets. The radiation and winds from the massive stars blow away this material, forming a comet-shaped tail that glows in the infrared. The energy from these huge stars sculpts the surrounding region on a much larger scale too. The pillars of gas and dust we can see here are compressed from the outside by the heated gas that fills the space around the massive stars and squeezed on the inside by their own internal gravity. At the heads of the pillars, brand new stars are emerging. The third generation of stars are born. This process is happening all over W5. Over here we see the so-called mountains of creation. Stars are forming here too. Compare this to the Hubble telescope image of the pillars of creation from the Eagle Nebula. These two images have the same scale. The mountains in W5 are much larger than the pillars of the Eagle, but both show the birthplaces of new young stars as they emerge, ready to take on the universe.